Okay, so 3y dx, this is 62. B just a square. Okay, so 3y dx plus 4x dy. So this is area 3y dA. So this is ADA. It's just the area, and it's counterclockwise. So the answer is 1. Answer is B. Okay, simple. 63 is a special question. Suppose you have a function continuous, strictly decreasing, real value. Start from f0 is 1, so this is 1. And f is decreasing, continuous, and go to infinity. This is the area. But from y perspective, this function is f inverse x, right? So there are two ways to write this volume. The first one is write this area. First one is this. The second one is from 0 to 1. F inverse y dy. Oh, this okay. So the answer is E. The answer is D. The answer is D. Right? If you just see the graph, so the answer is D. But can we prove this in rigorous way? Okay. So the second method, proof. So we start from this one. Well, I write x equals to f inverse y. So dx is f inverse y prime dy. So this is when x plugged in is 0, then the y is 1. Then when the infinity, the y is 0. So this one. And the f inverse y dx is this. So this is y. U dv this to uv minus v du. So integration by part. So this is y f inverse y minus f inverse y dy. So 0, 1, 0, 1. So when y equals 0, this is 0. When 1, then notice that the f 0 is 1. So f inverse 1 is 0. So this is also 0. So this is 0, 1 f inverse y dy. And when you change a variable, change this minus sign go in and flip the integral, you get this one. So the answer is D. The answer is D. Okay. So 62 the number the answer is B, and 63 the answer is D. Yeah, that's it.